Good afternoon to everyone. In 1999, I was in New York City and I watched a movie that didn't make any sense at all. The movie was this one that you are observing here, and basically what you see is the malaria parasite that seems like a kind of a banana shape approaching a human cell. And this, until now, seems totally fine, but then a few seconds later, the parasite just comes out. 60 seconds and the parasite gets in and gets out. And the question that immediately I made is that Plasmodium goes in and out of cells. We never had read that in textbooks, never saw this happening. I was not watching this movie by myself. I was with colleagues at New York University, and they all told me, let it go. This is an artifact. The movie was made 10 years before, and for some reason has never been published. This is totally an artifact of what's happening in vitro. But I want to bring you now a little bit back and explain to you exactly where I was and why I was there. So I work with a parasite that is called Plasmodium, and is the causative agent of malaria, and causes malaria that really affects red blood cells. And every 48 hours in humans, each parasite multiplies into 20, 30 parasites and goes out. The majority of the individuals can really recover from it, but there are many that cannot. And so, while there is a disease that many of you have never encountered in your life, still there are per year more than almost 300 million new infections per year and more than 600,000 deaths among children that are younger than 5 years old. So it's really something that is very important. But what I saw in that movie was not exactly this. So as I was explaining, malaria is caused when this parasite infects red blood cells. But for the malaria parasite Plasmodium to really enter us and be able to infect the red blood cells, prior to that, needs to be transmitted by a mosquito, Anopheles female mosquito, and these parasites that the mosquito transmits are not able to infect red blood cells. Prior to this, they obligatory need to go to hepatocytes, our liver cells. And there, each parasite is well known that they're replicating to 50,000 new parasites. Why it didn't make sense at all what I was seeing. So this movie was made 10 years before, so in '89, by Professor Jerome van der Berg. That was in a meeting that I was with him. And basically, he was a microscopist and putting parasites together with cells and always seeing what happens. And yes, he saw many times, he told us what he was observing in this movie. A parasite gets in and go out. And this was total nonsense, because the parasite gets in, and if it really encounters an hepatocyte, parasite gets in. And when it gets in, really, replicates into 1,000 new parasites. So what exactly was going on? And again, as I was saying before, all my colleagues saying, Maria, forget about it. This is not important. This is an artifact. But 24 hours later, I met another person, and I met Ana Rodrigues. Ana Rodrigues, I never met her before. I was returning to my house from a day of work. I lived in an NYU building, so she was also a professor at NYU, and she was in the same elevator that I was when I entered the elevator. I have seen her a couple of times, but we never spoke about it. I knew that she was a very recent recruitment from the department, but never spoke to her. When I entered the elevator, she was in a corner, and basically she was not crying, but obviously not looking happy as well. So she was a little bit strange. And, for 60 seconds, the same time that parasite takes in and go out of cells, I really debated inside myself, should I say something? Should I ask if she needs something? Or should I not do anything? Of course, with my upbringing up north in Portugal, I knew that was a good education to go and ask if you need anything. But I lived prior to be in New York City for 5 years in London, and I learned also that I should really, mind my own business and not really interfere with other people's lives. So for 60 seconds, probably I really debated this, and when I was coming out, because the elevator stopped and my flat was, in a floor below hers, basically I decided I turn and say, okay, if you really need anything, I live on apartment 365. And when I did that, she put her arm on it and said, really, I would love to talk to someone. I said, okay, let's go for a coffee or a tea. So we came down to a coffee shop. I had my tea, she had her coffee, and we discussed why she was so upset. And she was upset because she was employed, she was recruited to be at the parasitology department, and she was really interested to work with a parasite that is called Trypanosoma cruzi. And Trypanosoma cruzi is a parasite that is responsible for Chagas disease in South America. And she's interested on that, not because she was a parasitologist, but because she is really an expert on cell wounding. What is cell wounding? It is a capacity that cells have to really, when they suffer some kind of stress or they disrupt their plasma membrane, of resealing. So if they suffer a hole in the plasma membrane, they have the capacity to reseal. And she's interested to really approach this from the point of view of Trypanosoma cruzi, because it was known for many, 2 or 3 decades before, that Trypanosoma cruzi needs to really cause holes in cells to be able to establish inside of these cells. And she was interested to see how the mechanism is that, why is that important, etc. And when she arrived to the parasitology department with that dream in her life, the head of the department, Ruth Nussenzweig, basically told her, no way that you are going to do that until you get your own grant. Until then, you need to work on malaria because the majority of the department works on malaria. So she was very upset. And I told her, maybe malaria is the right place for you to work on. Because I saw a movie yesterday, and that movie, I'm almost sure that there is cytoplasm, and cytoplasm is what is inside cell, that is covered by the plasma membrane, coming out when the parasite is coming out. I think the parasite makes a hole. And again, as all my other colleagues the day before, she told me, no way that this is going to happen, Maria. So many people work on malaria parasite. People should have seen this before. I'm sure that they have reported if that would happen. But anyway, we finished our tea and coffee, and next day I met her, and we went again to Jerome van der Berg, asked, show us the different movies that you have on that. And it was obvious that the parasites, really, there was some holes poked by this parasite. And so for 6 months, we told no one. Everyone thought we were totally convinced that if we told them that we were going to test this hypothesis, would be considered totally crazy. So we told no one that we were doing this. I was working out of my time. I was a postdoc there. She was doing, other things for the head of department. We told no one. And we really, after a few months, we really had the proof that, in fact, every single parasite that is transmitted by Anopheles mosquito has the ability, and more than has the ability, always traverse at least 4 cells prior to infect the final cell and really be able to then multiply into thousands of new cells that then go to the blood and cause disease. So this is the type of thing that is like, it started with a very simple question and it really came to a kind of answer. Yes, the parasite does that, and really changed the textbooks. What it shows after that is that we really then there was many different groups around the world that show that indeed this is necessary because the mosquito deposits the parasite in the skin, the parasites need to reach blood vessels, the blood capillaries, then travels to the liver, and in the liver sinusoids also needs this capacity to traverse this other side. I can tell you that there are thousands of papers now published on something. We started a new field in the malaria type of research, and really by something just having a simple question and be able and not being afraid of answering this question. The interesting thing is that by that time, when I finished this and work with Anna and my postdoc, I basically moved to Portugal and started my own lab. The field at that time started to be so crowded that I decided that I was not going to work directly on that, and I wanted to start a new niche. So I started something else, of course, never forgetting that is this and following some aspects of it. 2 decades later, okay, 2 members of my team basically stumbled on some kind of data that really made us remake the question. It's really this cell traversal, that is this capacity of parasites to migrate through cells, really required for sterile immunity. So many of you is asking what is exactly sterile immunity. And the best example that I can tell you is about measles, sarampo. So measles is the type of infection that when you have it, either you die or you survive, you never have it again. Okay? The vaccine does the same. The vaccine, basically, when you take the vaccine, you never get. So it's able to establish sterile immunity. Unfortunately, for the malaria field and for the malaria infection, there is no sterile immunity in the field. So basically, people never get sterile immunity. When they live in endemic areas, they always keep getting infected, with less probability of dying as they get older, but they always get infected. Sterile immunity doesn't exist. But many years ago, in fact in 1967, Nussenzweig published an amazing paper that really shows that if you have parasites from the salivary glands of mosquitoes, so inject in high amounts, and you just attenuate them, so they are now alive, they are able to reach the liver, but if you do radiation, so they cut their DNA, so they are not able to properly replicate, etc., if you really attenuate them and you inject a huge amount into mice and later on into humans, it was also shown, mice and humans really reach sterile immunity. And what these people in my team now show is that it seems that cell traversal is really important for inducing that sterile immunity. So you can ask why this was not done 20 years ago. And it was not done 20 years ago because we didn't have the technology to really have, we could have the question, but not to approach the question with a proper answer. So basically, what people in my lab did in collaboration with other people around the world, they produce genetically modified parasites that either are wild type, which means that they are transmitted by a mosquito, they traverse several cells and then they fix in the final cell where they multiply into thousands. If you attenuate them, they are really not able to multiply, and we know that these ones really confer sterile immunity. But then we use parasites that are not able to traverse cells, but we can modify them in a way that they still can reach the liver in a way that we can use them as a vaccination type of strategy. Or parasites that keep traverse lots of cells, but never fix in one final cell. So when we did this, and these are 3 different parasites, then we can go and really challenge them, so infect them with live parasites, and see which ones are really protected and have sterile immunity, and which ones don't have. And so basically what you have here is that if it's wild-type parasites, and this was done in mice, these mice are protected. But if you have parasites that are cell traversal deficient, they are not able to do cell traversal, they are not protected at all. But if they are the parasites that they keep traversing, but they never really end up in a cell, they are still protected. So it shows that indeed cell traversal is not only necessary, but is sufficient to induce sterile immunity. And this changed a very important concept in the malaria field and in the vaccination field. So it changed that it's not just the amount of protein of the parasites, it's not the amount of antigen that really can make a very good or bad vaccine. It's really, in this respect, a kind of a parasite behavior. And of course, telling a very long story, Andrew and Anna, the people in my team, have worked on this for 5 years. They really show that this parasite behavior, what it does, is like breadcrumbs, migalhas. So basically, when they go through cells, they leave material behind, and so this is present to the immune system in a much more efficient way and in a way that is specific to then provide sterile immunity. So of course this is just, again, the first few days of new discoveries. Although we have just finished one discovery, we have now many questions. Can we really mimic this without using the parasite? Can we really, what exactly the parasite is doing going through cells? What it induces in these cells? So many questions arise there. So what I think we learn from these this discovery that happened in between 1999 and 2001. And I think it's 2 ways. Many times when I tell this story to friends and this and that, people say, wow, you were really lucky, okay? You were lucky that you were on that day with Jerry Van der Berg because you saw this movie. You were lucky that you met Ana Rodrigues. Everything was luck. But I really think that, chance and luck only exist I think in really, and only bear fruit, in really when you really have a nice and work growth. And let me tell you what I mean with that. Yes, I met Jerome van der Berg. On that meeting, 10 other colleagues were there. Many of them have seen this movie before, because the movie was done 10 years before. Yes, I met Ana Rodriguez also, but we really came to a conversation and really were thinking about this through and had the courage for 6 months not telling anyone and still putting our energy on it. I think basically what is showing is that you need the environment, but you also need trained minds. Anna has done, has been trained in Yale University and then at Curie Institute. I have been doing my institute in a wonderful place, NIMR, Mill Hill in London before. So really we're trained to do this, but at the same time we had an environment that really allows us to be creative, to have freedom. And this is because we have a society that is really investing in people and an environment for science. And that, I think, is very important. But also brings a concept. And when we are here in a program that's about reprogramming the future and about technology, I really think that sometimes the best technology is not really, cannot fit a ship, but can fit a really good question. And I think there is nothing that can substitute an amazing question. And so the last message that I want to leave to you is that never underestimate a question with no obvious answer. Thank you so much.